The recipes are ready and now it's time to serve the meal. This represents the final stage of the machine learning workflow, model serving. Model serving consists of two steps. First, model deployment, which we can compare to serving the meal to a hungry customer. And second, model monitoring, which we can compare to checking with the waitstaff to ensure that the restaurant is operating efficiently. It's important to note that model management exists throughout this whole workflow to manage the underlying machine learning infrastructure. This lets data scientists focus on what to do rather than how to do it. Machine learning operations, or MLOps, play a big role. MLOps combines machine learning development with operations and applies similar principles from DevOps to machine learning models, which is short for development and operations. MLOps aims to solve production challenges related to machine learning. In this case, this refers to building an integrated machine learning system and operating it in production. These are considered to be some of the biggest pain points by the ML practitioners community, because both data and code are constantly evolving in machine learning. Practicing MLOps means advocating for automation and monitoring at each step of the ML system construction. This means adopting a process to enable continuous integration, continuous training, and continuous delivery. So what does MLOps have to do with model serving? Well, let's start with model deployment, which is the exciting time when our model is implemented. In our restaurant analogy, it's when the food is put on the table for the customer to eat. MLOps provides a set of best practices on the back end to automate this process. There are three options to deploy a machine learning model. The first is to deploy to an endpoint. This option is best when immediate results with low latency are needed, such as making instant recommendations based on a user's browsing habits whenever they're online. A model must be deployed to an endpoint before that model can be used to serve real-time predictions. The second option is to deploy using batch prediction. This option is best when no immediate response is required, and accumulated data should be processed with a single request. For example, sending out new ads every other week based on the user's recent purchasing behavior and what's currently popular on the market. And the final option is to deploy using offline prediction. This option is best when the model should be deployed in a specific environment off the cloud. In the lab, you'll practice predicting with an endpoint. Now let's shift our focus to model monitoring. The backbone of MLOps on Vertex AI is a tool called Vertex AI Pipelines. It automates, monitors, and governs machine learning systems by orchestrating the workflow in a serverless manner. Imagine you're in a production control room, and Vertex AI Pipelines is displaying the production data on screen. If something goes wrong, it automatically triggers warnings based on a predefined threshold. With Vertex AI Workbench, which is a notebook tool, you can define your own pipeline. You can do this with pre-built pipeline components, which means that you primarily need to specify how the pipeline is put together using components as building blocks. And it's with these final two steps, model deployment and model monitoring, that we complete our exploration of the machine learning workflow. The restaurant is open and operating smoothly. Bon appetit!